All right, 7th graders, we're going to talk about what inductive reasoning means. Inductive reasoning basically just means using logic to find the answer.
Guys, be quiet!
Find the answer. So, looking at a pattern, trying to figure out, based on the pattern, what the answer is. Finding an answer based on a pattern. Then, a conjecture is writing down what you think the rule is for the pattern. A conclusion that you make based on the pattern. So, on page 35, it shows you some patterns. Look at the pattern for example 2. The number starts at 30, and then it goes to 25, and then 20, and then 15. So, in that second example, what would the next number be? It's a basic example of using inductive reasoning, looking at the pattern, figuring out how you get from one to the next, and then using inductive reasoning to figure it out. What would the next number be? 10, yep. And the conclusion that you could draw from the pattern? What's the conclusion that you would draw from that pattern in example 2 in your book? What is the rule? Page 35. What is the rule? Counting back by 5. So the rule is to start at 30 and subtract 5. Or add negative 5. And that's how you write down the rule, or the conjecture it's called. Let's look at your worksheet. Write the rule for each pattern, find the next 3 numbers in the pattern. How can you find a pattern in this? One of the ways to find patterns in numbers, the first step is to figure out the difference in the numbers. So to add the second one, subtract the first one from the second one. If you subtract the first one from the second one, you get 3. So that means you're adding 3 each time. It's the basic one. 3, 6, 9, 12, 15, 18, 21, 24. And then the rule is to add 3. Start at 3. Always tell why you're starting, because you're not always starting at 0. So start at 0 and add 3. That's the first one. The second one. 1, 2, 4, 8, 16. So when you subtract the first 2, you get a difference of 1. Then you get a difference of 2. And then you get a difference of 4. And then 8. When you look at those numbers, what's the difference in those numbers? How can you see the difference in those numbers?
Multiply by 2.
Yeah, it's the difference is doubling. So the difference is 1, and then the difference is 2. 2 times more. Doubling the difference. So, starting at 1, add the difference times 2. Add the difference in the numbers times 2. So what would the next number be? 32, yep. 16 minus 8 is 8. And if we double that, that is 16. So you add 16 and get 32. Then 64. And then 128. How about number 3? Cool?
You double the first.
Oh, I know.
You add 1 and then you multiply by 2. So 1 and then multiply by 2. So starting at 6, you add 1, and then you multiply by 2, and then you add 1. Very good. Yeah, I was just misunderstanding what you were talking about. You had it right away. That's right. Add 1, multiply by 2. Add 1, multiply by 2. Add 1, multiply by 2. So what would the 31, what's 2 times 31? 62. And then add 1, 63. And then multiply by 2, 126. These numbers are reducing, aren't they? 34, what's the difference between 34 and 27? Notice that we're always subtracting the first 2 numbers to find the difference. What is the difference, Jennifer?
Subtract by 7.
Subtract 7. Yep. Or you could say add what?
Negative.
Or add negative 7. Yep. So from 6, if you add negative 7, what do you get? 6 plus negative 7 is negative 1. And then 8.
Negative 15.
15.
Weird.
So we're starting at 34. Make sure you write that as part of your answer, where you're starting. Start at 34 and add negative 7. Add negative 7. Or subtract 7. Make sure that you write the words, or you show what's happening. Now, another part of this is figuring out if statements are true or false. And then figuring out if there is a counterexample. A counterexample is an example that goes against what is being stated. So, in the first statement, all roses are red. That's false, isn't it? A counterexample is an example that goes against the statement.
No.
Some roses are
White.
blue,
Blue. Yeah.
purple, pink, yellow. Pretty much you name multicolored.
Yeah. A rainbow.
Let's look at the second one. A number is divisible by 4 if the last 2 digits are divisible by 4. If the last 2 digits are divisible by 4, then the number is divisible by 4. So we have to start with a 2-digit number and check whether or not this is a true statement. Check whether or not this is a true statement. Is 11 divisible by 4? No. And is the number 11 divisible by 4? The 1, the last 2 digits? 12? Yes. Yep. How about a 3-digit number? What about 112? The last 2 digits are 12.
Yeah.
Is that divisible by 4?
Yes.
So we'd have to check. 112 divisible by 4. You could use your calculator,
Yeah, it is.
or you could
Use your head.
just use your head, figure it out.
It is
What number?
4, 8, 12, and 40. It would be 4 goes into 20, 10 times 40, 80, 100.
So,
Oh wait, never mind. I'm smart. 16. Yeah, times 12.
okay.
Because mine is 120, 116.
How about 116?
Yeah.
Yeah. What about 111?
No.
No. So, are if the last two digits, based on our examples? Yeah, it is true. If the last two digits are divisible by 4, and you might remember that when we studied this last year, figuring out divisibility rules for a number. How about the number 7? The difference of two numbers is always less than at least one of the numbers. The difference of two numbers less than at least one of the numbers. Wait. Because you're subtracting. What if you're subtracting a negative though?
Ooh, no.
Well, you just like leave.
So think of an example where you're subtracting a negative.
-5 or -5. -7.
So negative 5 minus negative 7. What's negative 5 minus negative 7?
Negative 12.
It's 2, isn't it? We're not adding negative
2?
because minus minus equals plus.
I knew that.
Wait, no.
I think
You
you
said
see it.
-7 minus negative.
Negative 5
Oh.
minus negative 7
Oh, yeah, well then.
would be negative 5 plus 7.
I knew that.
So the answer is 2. Is the difference in those two numbers less than one of the numbers?
Yeah.
Greater than. Is it always less than? No. Sometimes it's greater. And the counterexample is if you are subtracting negative. If you're subtracting negative, finding the difference that way, then your answer is more than both numbers. Yeah, sometimes patterns are in shapes. What pattern is happening here?
They're getting more dots.
Getting one more, right?
Yeah.
So what would be the logical position of the next one?
The bottom left corner.
Bottom corner. So if we go here, and then these two corners, and then add a dot in this corner, the logical progression is to have a dot in that corner.
Knowledge.
How about this one?
Cool.
Wait, so what's the
Circle.
logical explanation?
And a triangle. A triangle and circle. Then a circle and a square would be the next progression. Brett?
A circle and a square.
So what would be on the outside?
Square.
The square, and then
Circle.
a circle inside of it.
So we should draw
Very
that.
good. Yes. Yep. Number 10. This has a triangle with the shaded part at the top. And this shaded part goes down to the left. Then it goes to the center. Which position is left? Daria?
It goes on the right.
Down and to the right. Yep. Very good. How about this one? does the dot go? Nate?
So, and then on the last one,
What's the progression? Can you describe
it's
it?
like the dot is like
Clockwise.
it's
Yeah,
circling right.
So it's, yeah, kind of like a clock. It's twisting or it's rotating.
I was about to say circle.
It's rotating. So the next progression would be the dot sort of at 9 o'clock position, right?
It would be like this. The
Yeah.
dot's right here.
So like at 9 o'clock position,
Oh, yeah, this is
pointing to the 9. Yep,
it would be like 3.
very good.
It would be like 3 o'clock.
Any questions on this? Hey,
Is this graded?
not yet. This is going to be on your quiz on Friday. Quiz on Friday.
That's 5 pages.
Any other questions? Finish the sheet.
And this stuff.
Where do we hand